Hi, my name is dr. Ahmath. In this video lecture, we are going to discuss about vectors. Well, we are going to introduce vectors, and also we're going to discuss about operations with vectors geometrically. So essentially how to add the vectors, how to subtract the vectors, and how to change the lengths of a vector. Well, vector is a mathematical quantity which has the two attributes. Essentially, it has a direction and it has a magnitude. And it is superbly useful to use the vectors for the quantities which has 2 or 3 or even more attributes. So most of the popular examples of usage of vectors are the physical quantities, such as force, for example, or the velocity. The force has the magnitude, so it's essentially the quantity of the force and its direction. So if you look to the gravitational force, which is applied to all of us on the Earth, it is going to have a direction which is centered to the center of the, which is directed to the center of the Earth, and its magnitude is proportional, it appears, to the mass of an object. The higher the mass, higher the magnitude of the force. So essentially, it is easier for us to use a vector in order to denote these two attributes of the force at the same time. Well, another example of applying the force would be like, so if you would like to kick the ball, it is essentially important for us to define in which direction you would like to apply this force so that the ball may go in the different directions. So vectors are really useful in physics or in chemistry, but at the same time, vectors are superbly useful in computer science as well. Like, we are going to store the data in the vectors or in forms of the matrices. Well, today we are going to do the operations with the vectors mostly geometrically, but in our next lectures we're going to discuss about how we can do the operations with the vectors algebraically, which is more suitable for the computer science. So vectors on the rectangular coordinates, or in 2D, is going to be denoted as an arrow which has the starting point and the ending point. The coordinates of the starting point are going to be given as a 2 tuple, as the 2 numbers. For example, here the A is going to be given with the 2 numbers 2 and 3, and the B is going to be given with the numbers 7 and 8. So this pair of numbers which are written inside the brackets is essentially called as an 2 tuple. So it is simply called as a 2 tuple because the order of the 2 numbers is important. So essentially 7 and 8 is going to denote something different than 8 and 7. So the order is important. So 7 is coming first and 8 is coming second. It is different than 8 is coming first and 7 is coming the second. So essentially, the vectors are going to come with the 2 points, the starting point and the ending point. And if you would like to store the vectors, you have to store 4 numbers. Well, if you go to the higher dimensional spaces with lots of coordinates for every point, the starting point and the ending point, you are required to store lots of numbers. So one of the ways to optimize your storage to store the vectors, and also in order to optimize your working experience with vectors, people have figured out something which is called the position vectors. So position vectors. Well, you've got a vector now which starts with some point A, which ends at some point B. And the vector has 2 attributes, as we have stated in the beginning of the lecture. It has the direction and the length, the magnitude. Well, geometrically, the magnitude of the vector is proportional to its length. The length and the direction. Well, unless you're not going to change these 2 attributes of this vector, you can move this vector to any place it appears. For example, I've got this vector with some length, with some direction, and I can place this vector to here, for example, or to here, or even here. And the best way to put all of the vectors, so the best place to put all of the vectors would be the starting point of the coordinates, or the origin. Because if all of the vectors would start from the same point, essentially, from the point 0 and 0, you would not store this anymore. The only thing which you have to store in order to describe the vector would be the ending point of this vector. Well, the ending point of this vector is going to be, so let's do this. So let me first of all write down its starting point. The starting point was 3 and 2. It was A was the coordinates 2 and 3, sorry. The ending point had the coordinates 7 and 8. B has the coordinates 7 and 8. And now we have placed this vector to somewhere else. So it is going to start from the origin, 0 and 0. So, and it is going to have the following coordinates. It is going to have 2, 3, 4, 5. 1, 2, 3, 4, 5 here as well. 5 and 5. So this vector now is going to be denoted simply as the U, the small Latin letter, equal 5 and 5. Okay, so the position vectors start from the origin. This is the definition of the position vector. And in this case, our vector U is going to be denoted as 5 and 5 inside the brackets. So it is going to be simply the coordinates of its ending point. The question is how we got this point from the two given points, A and B. The way how you're going to get is very easy. So I would like to explain you our motivation, how we are going to do this first of all. So you see, so you are replacing this A to here. So you are forcing to make the coordinates of this A, the starting point, to be equal to the 0 and 0. What you can do, what you have to do in order to make this 2 and 3, 0 and 0 is simply subtract 2 and 3. Right? If you subtract 2 and 3 from the 2 and 3, you're simply going to get 0 and 0. And at the same time, since you're doing this was the starting point, in order to keep the balance in terms of the length and the direction of the vector, you have to do the same thing with the ending point. Well, I'm going to subtract the 2 and 3 from the ending point as well, and if you do this component-wise, you're going to get 5 and 5. So essentially, in order to get this vector 5 and 5, it appears you just need to subtract the starting point from the ending point, simply. Okay, so the only thing which confused me a little bit is the notation. So you see, so I'm denoting points using two tuples, right, with the pair of numbers which are written inside the brackets, and I'm denoting vectors with the two tuples as well. Well, the only thing which is making the difference between this two notation is the equality sign. Well, when I'm going to denote a point, I usually use the capital Latin letter A, for example, with the coordinates 2 and 3 without equality sign. And whenever I would like to denote a vector, I'm going to write this down as the U is equal to 5 and 5. Well, I'm going to denote the points and the vectors using the two tuples, or in general, we're using the n tuples, but the only thing which is making difference in terms of the notation is this equality sign. Well, let's do one small example on finding the position vector. So the position vector is a vector which starts from the origin, right? So let's say you are given a vector with the starting point A, 1 and 2. So let me draw this, 1 and 2. So this is going to be the A. And it was the ending point 4 and 2. So 1, 2, 3, 4, 4 and 2. Well, I think it's going to be really easy to do this. So B is going to have the coordinates 4 and 2. So this is going to be my vector here. So if you would like to find a position vector, essentially, what you have to do is you are going to find a U to be equal to B minus A in this case. It is going to be 4 and 2 minus 1 and 2. And again, it's really important for us to work component-wise with the two tuples. So again, the two tuple is the pair of numbers which are written inside the brackets, where every position is important. So you cannot really mix up with the positions. Okay, so let's assume that this position can be a potato and this position can be an iPhone. So there are two completely different things. So you can add up the two tuple. Potatoes was potatoes, iPhones was iPhones. Okay, so you have to work pairwise. So 4 minus 1 is going to be equal to the 3. 2 minus 2 is going to be equal to the 0. And our vector here is going to be something like this. So you may see here that the blue vector has the same direction as the red vector, and its length is the same as the length of the red vector. So this is how we're going to just replace the vectors. So you can see here that instead of storing 4 numbers now, we just need to store 2 numbers, 3 and 0, to store this vector. So well, this vector, blue vector, is going to be called as a position vector. So this is one of the really important concepts of vectors. So another important concept for vectors is the addition operation. So if you're given 2 vectors, u and v, not necessarily position vectors, any vectors, u and v, so how to add them up geometrically, right? So it is really important for us to understand how to add the vectors geometrically due to some sophisticated algorithms in linear algebra, which is really applicable to computer science. So many sophisticated algorithms like the face recognition or the image compression is based on the vector operations, this kind of vector operations, when you're going to add the 2 vectors geometrically or subtract them geometrically. So if you've got the u and v, and if you would like to add them, it appears, you just need to get the second vector and put this to the end of the first vector. So essentially, I'm just going to replace the v to the end of the u. So since I can move the vectors to any place without changing its direction and the magnitude, it is a valid operation. And the resulting vector u and v, u plus v, sorry, is going to be the vector which connects the starting point of the u and the ending point of the v, it appears. So simple. So let's say I've got the 2 vectors, u and v, I would like to add them. So let's do this together. So now, in this case, 1 and 2 is going to be the ending point of the vector, right? So this is going to be the u vector. And the v vector is going to be 4 and 2. 1, 2, 3, 4. So this is here, 4 and 2. This is going to be the second vector. This is the v. And if you remember, if you would like to add the 2 vectors, what you have to do is essentially, you just need to replace one of the vectors to the end of the second vector. So I'm just going to move the v, so v to here. So 4 and 2, it's going to be 5 and 4, right? 5 and 4. So this red vector is going to be the same as the v vector. So this is the same as the v. V can be in any place unless you're not changing its direction and its magnitude. And the resulting vector u plus v is going to be this vector which connects the starting point of the u, the first vector, and the ending point of the v, the second vector. So this vector is going to be u plus v. Well, interestingly, this vector u plus v is also a diagonal of the parallelogram, which is obtained by using these 2 vectors. So if you just create this vector u, so u, v, v, and its diagonal, which is going in between of these 2 vectors, u and v, is going to be the addition of these 2 vectors. So now you have 2 methods of adding the 2 vectors. Either you're going to put them start from the same point and then you're going to draw a diagonal of a parallelogram. Either you're just going to replace one of the vectors to the ending of the first vector, then you're going to connect the starting point and the ending point. Well, we are going to subtract the 2 vectors in pretty much in the same way. So if you've got the u and v, and if you have to find a vector u minus v, we are going to use this operation again, so this addition operation. So well, instead of subtracting the v from the u, what I'm going to do is I'm going to add the 2 vectors. So well, in this case, I'm going to add the u and minus v. Well, again, if you've got a vector v, in order to find the negative v minus v, what you have to do is you just need to find a vector which has the same magnitude, which has the same length, but in the opposite direction. Well, the minus v is going to be something like this, which has the same length, but its direction is opposite. So now we know how to add the two vectors, right? So if you've got this one vector u and another vector minus v, in order to add the second vector to the first vector, you need to replace the second vector to the ending point of the first vector. So I'm just going to put the minus v to the ending point of the u. And then if you remember what you have to do in order to find the resulting vector u and v, you need to connect the starting point of the first vector and the ending point of the second vector, which is going to be u plus minus v, or u minus v. Well, this is a little bit difficult method of subtracting the vectors, right? Because you need to create minus v first of all, then you have to put this to the ending point of the first vector and so on. Another easier way would be to just put both of the vectors u and v to the same point. So starting from the same point, then just connect the ending point. So in this case, you would get the same vector. So this vector here, which is like u plus minus v, is identical with this vector. So they are the same. Okay, so the easy way to get the subtraction of the two vectors would be to just put both of them start from the same point, u and v here, then just add them. Okay, connect their ending points. So in this case, it is going to be either u minus v, either v minus u, and this is the most difficult part. So how to find the direction? So previously, when we add the two vectors, directions was intuitive natural. You're going to connect the starting point of the first vector with the ending point of the second vector. Now, whenever you're going to connect the two ending points, it is tricky to find the direction. Well, the direction would be always from negative vector to the positive vector. So if you're going to find u minus v, so it is going to go from minus v to the u, from negative to positive always. Okay, so the last operation which I would like to discuss with you is the scaling the vectors. And if you've got the vector u, what happens if you multiply this vector to some constant, for example, 1.5, 2, 2.5, or to any constant? So what happens is essentially it is going to change the length. So it is not going to change the direction. So if you multiply a vector to a constant, so you can't really change its direction. Okay, so you can change the direction of the vector by adding another vector or subtracting another vector. But if you would like to, but you can't really change its direction by just multiplying it to a constant. So let's do an example. So again, I've got a vector with the coordinates 1 and 2. That's going to be this vector. And if you are required to find a vector, which is 2u, what you can do is you just need to copy this vector and put this again to here, this one, and connect them. So this vector is going to be 2u. This vector is u, this vector is 2u. Again, so you can see here that the blue vector is different from the purple vector u, only in its length, not in this direction, not in its direction. Well, in this video lecture, we've discussed about the vectors. We discussed about the vector operations, mostly geometric operations, how to add the two vectors, subtract the two vectors, and how to scale the vectors. Well, in our next video lectures, we're going to discuss about the algebraic operations over the vectors as well. Thank you very much for your attention. I hope that this was helpful for you.